In Chapter 5, Section 5, we move on to graphing the remaining 4 trig functions. Now, remember when we talked about domain and range, while the domain of sine and cosine are all real numbers, for the remaining 4 functions, we have places where our domain is undefined. So we have values that are left out, values where the function does not exist. And just like in college algebra, those places where our function is undefined result in asymptotes. We're going to start by graphing tangent. Remember that for tangent and cotangent, our period starts as pi instead of 2 pi. So you only need to look at the interval of values that covers that period of pi, because after that the graph is going to repeat. Now remember, we're discussing the parent function. That period will change according if omega is something other than 1. It's just that our period is pi over omega instead of 2 pi over omega. Now where is tangent undefined? Remember that tangent is y over x. So tangent is going to be undefined anywhere I have x as 0. When that happens, we have a vertical asymptote. So where is x 0? If I think about my unit circle, x is 0 at the pi halves. So tangent is going to be undefined anytime I rotate around to a pi half, odd pi half. Our chart is already started for us. You can see that at negative pi half, and that's where we usually, just kind of our convention is that we are going to graph one period of tangent from negative pi half to positive pi half, instead of going from positive pi half to 3 pi halves. So basically, we are starting here thinking about having gone back to negative pi half, and we are graphing one period to positive pi half. That's what that looks like on the unit circle, linked back to the unit circle. Just like with our previous graphs, we're not going to worry about those smaller values that fall in between. We're just going to look for the major points. This time, my 5 major points are going to be considered at those vertical asymptotes where it is undefined. So let's go ahead and sketch in some undefined vertical asymptotes on our graph. And then we have values at the quarter values, because we divide this period of pi into quarters. Well, halfway between is going to be 0, and then halfway between negative pi half and 0 is negative pi fourths. And then halfway between 0 and positive pi halves is a positive pi fourths. So there are 1, 2, 3, 4, 5 major points that we're going to graph. It filled in an approximation for us at negative pi thirds. We're not going to worry about graphing that. Our continuous curve is going to hit it. So at negative pi fourths, what is the value for tangent? So tangent here, that's one of my 45s, my pi fourths. So the cosine and sine, the y and the x are the same, which means it's either 1 or negative 1. When I'm in quadrant 4, my tangent function value is negative 1. So the point that I plot is negative pi fourth, negative 1. At 0, I'm here, because y is 0, tangent is 0. So that hits center. And then I've got positive pi fourth, tangent there is a positive 1 because I'm in quadrant 1. So let's plot our points. Negative pi fourth is going to be right here in the middle. Positive pi fourth is going to be right here in the middle. Those are our quarter values. 0's at the half, and then we have our quarter values. So we have negative 1, negative pi fourth, negative 1, our center, and then we have positive 1. Now, these quarter values represent what we previously think of as our amplitude, A. Now, for tangent and cotangent, that's not an amplitude. That gives us this curve It shows us where our quarter value falls. Our tangent function graph is increasing as long as tangent is positive. And it looks a lot like a cubed function, right? So tangent, positive tangent is increasing. If I kept going, I would have this function repeated between pairs of asymptotes all the way to positive and negative infinity. Okay, so let's fill in some information in our table down here about the properties of our parent tangent function. The domain of tangent is going to be all real numbers except those odd pi halves, odd multiples of pi half. So if I want to write that out, I'm going to say the domain is all values of x such that x is not k pi half, where k is an odd integer. Where k is an odd integer. There we go. The domain is all values x such that x is not k pi half, where k is an odd integer. The range is from negative infinity to positive infinity. It is all real numbers. Tangent is an odd function for the parent as long as we don't shift it left or right, as the symmetry is with respect to the origin. It's got that twist in the middle. It's periodic with a period of pi. It's actually pi over omega. That value for omega will change the period, give you a horizontal stretch or shrink. X-intercepts are in the form of x equals n pi, where n is any integer. So we hit the x-axis as long as we don't have any adjustments. At 0, we would hit it again at pi, at 2 pi, at 3 pi, at negative pi, negative 2 pi, etc., etc. And the y-intercept is at the origin. Vertical asymptotes occur at those odd pi halves. So we're going to say at x equals k pi half, where k is an odd integer. Okay, so those are our properties of our tangent function, our parent tangent function. Now we're going to do one more example of a tangent function, and then we're going to switch to cotangent. I want to point out to you before we go on, tangent is y over x, cotangent is x over y. Tangent, positive tangent, is an increasing function. Cotangent flips and is a decreasing function. It also has a shift so that the vertical asymptotes aren't at the pi halves, they are at the full values of pi. But tangent and cotangent graph are extremely close, just like sine and cosine graphs. Okay, let's do an example of a tangent function graph. Now, I did not go back and adjust this to what I wanted it to be. I will try to do that before I post it for you. We're not going to graph what is given to us. We're going to graph a different tangent function. So I want you to change that to y equals tangent of 2x minus 1. So let's think about what we're doing as far as transformations here. Our basic function is tangent, and tangent is an increasing function as long as it is positive and I don't have a negative out front here. What two transformations are we doing? Well, first we have a period change because of that value 2. Omega is 2, so our period is pi over 2 instead of just pi. So our period is pi half instead of pi. We have a horizontal shrink. We've shrunk it in closer together. And then our second shift is this minus 1 tacked on at the end. That's a value for beta. So our center moves down 1. And I'm going to go ahead immediately and sketch that new center in so I don't forget to do that. When I center my function, it's going to center down here at -1, not at the x-axis. Okay, so let's think about working through graphing this tangent function. Tangent is increasing. As long as it's positive, we don't have that negative out in front. Our vertical asymptotes start at the pi halves. So we have our equation that helps us find our vertical asymptote no matter what omega is omega x equals plus or minus pi half. Well, omega here is 2. That changes the period. So we have 2x equals plus or minus pi half, which means I'm going to divide both sides by 2. When I divide by 2, that's like multiplying times a half over here. So my asymptotes, instead of being at the positive and negative pi halves, are at positive and negative pi fourth. So let's sketch in those asymptotes. We've got an asymptote at negative pi fourth and an asymptote at positive pi fourth. Now that little bitty skinny space between those two asymptotes are where my function is going to fall. So the next step is going to be to divide that space into 4 equal intervals. So we have center here at 0, and then we've got our quarter values, first quarter and third quarter. Those are going to be at negative pi 8 and positive pi 8. Negative pi 8 and positive pi 8, because this is my pi fourth. That gives me my A. How far up, how far down do I go with those quarter values? Well, A is 1. Tangent is increasing, so I'm going to start low and finish high. My center is here at, I guess I could have marked my quarter values up there, negative pi 8, positive pi 8. My center is at -1 because of that shift down. I'm going to go from -1 down 1 for the first quarter value, and from center up 1 for this third quarter value. And when I sketch this, I want to show my curve. It should look like a really stretched out cubic function. It should be a little, well, no, not really, a little bit curvier. That looks decent. Okay, so now this original one it asked me to do had a phase shift instead of a period change. It was going to shift it to the left pi fourth. So I would have taken my function and just shifted it pi fourth over. But I wanted us to get a good graph of one without that phase shift before we attacked a phase shift one. Let's do a cotangent graph. For cotangent, the period, just like tangent, is pi. So you only have to look at that interval of values. And after that, it's just going to be a repetition. So once more, we are not going to be worrying about those kind of in-between points. We're just going to be looking for our major values. Cotangent is x over y. So it's going to be undefined wherever y is 0 on our unit circle. Well, where is y 0 on our unit circle? Y is 0 at the full values of pi. So that's where my asymptotes are going to show up. At 0 and at pi, we have our function undefined. So we have vertical asymptotes there. So I have a vertical asymptote at 0, and I have a vertical asymptote at pi. Now, you know what? We go from negative pi to positive pi, so I'm going to go ahead and we're going to sketch 2 full periods of our cotangent function. Now, cotangent is a decreasing function. Keep that in mind, that cotangent is a decreasing function, as long as it's positive. And let's go through and let's figure out our points to sketch our cotangent function. Okay, so it's undefined at 0. Now we divide our period into half and then into quarters, both directions. So we're going to have pi fourth, pi half, 3 pi fourths, pi, and then negative pi fourths, negative pi half, negative 3 pi fourths, negative pi. It is very important to show your axes numbered. For pi fourth, what is the cotangent function value? Well, that's right here. That's going to be a +1. So there is the coordinate pair for that point. When I get up here to pi half, x is 0, so my cotangent function value is 0. That's my center. And then I go over to 3 pi fourths, and that's in quadrant 2, so cotangent is going to be a -1. So there are my coordinates for my major function values for this one cycle. So cotangent is decreasing. It's going to start high. It's going to start at A, go through center, go down to A. So there is one cycle of our cotangent function. Let's do another. We do our A value, our center, and our A. No, we're starting high, ending low, because it is a decreasing function. There is the second period. So we did 2 cycles of cotangent. All right. Let's talk about, I know this section goes really quickly. Let's talk about graphing cosecant and secant. Now, the wonderful thing about graphing cosecant and secant is that you really don't focus on graphing cosecant and secant. You graph the reciprocal functions, sine and cosine, and then you just build it off of that. Right here, and we're going to read through this in just a second, but I want to point out to you right here, this is a sine wave right here. This is a sine wave. I go through center, up, and I've got 2 cycles of my sine wave here. From 0 to 2 pi, and then from -2 pi to 0 is another cycle of my sine wave function. These parabolas that open up from the max and down from the min on my sine wave, that is my cosecant function. So you see, I don't actually have to graph cosecant, I graph sine. Anywhere I hit center, I hit a 0, that gives me a vertical asymptote. And then anywhere I have a max, I do a parabola up, and anywhere I have a minimum or a trough, I do a parabola down. So, to graph the cosecant and secant functions, recall the relationship between these functions and sine and cosine. Cosecant is the reciprocal of sine of x, and that needs to be fixed. Secant is the reciprocal of cosine x. Because of this reciprocal relationship, graphing involves finding the reciprocal of the y-coordinate. You graph the sine or cosine function. Since pi 6 1/2 is on the sine function, then pi 6 2 is on the cosecant function, reciprocal of 1/2. Since the point pi 0 is in the sine function, there exists a vertical asymptote on the cosecant function. And then we talk about cosine and secant down here. Since the point pi 3rd 1/2 is on the cosine function, you have pi 3rd 2 on the secant function, and pi 1/2 0 is on the cosine. That means there's a vertical asymptote there at the secant function. So again, we start by graphing cosine. Sorry, I got off. Anywhere you had a 0, a center, you turn that into a vertical asymptote. And then to get your secant function graph, where there's a trough, you have a parabola going down, and where there's a peak, you have a parabola going up. That is one cycle of secant. This is 2 full cycles of secant. And the same with my cosecant. There's 1 cycle of cosecant. There's 2 cycles of cosecant. And then it has a little one for us to practice on down here. We have a small graph. Just to reiterate what we're doing, it says we're going to graph. You know what? We're not going to do the one it gives us again. I need to change this. I apologize for not having changed that in advance. We are going to graph y equals 2 cosecant of x minus 1. So to graph that, cosecant function, what we're actually going to work on, what we're actually going to graph, is y equals 2 sine x minus 1. Okay, so for this, we have a is 2. That gives us our amplitude of our sine function. And beta is a -1, so that means we have a center that has been moved down to -1. There's my center. Now sine starts at center and goes up. Here is my y-axis. So sine is going to start at center. I have an amplitude of 2. So remember, we're going to go from, here's 2 pi. So we have pi half, pi, 3 pi half, 2 pi. There's our 5 points. So we go up to our peak, 1, 2, back down to center, down to our trough. It's going to be down here at -3, and back to center. So that is one cycle of our sine wave that we have to start with to get our cosecant graph. Now, anywhere I had a center, that is a vertical asymptote. So I have 3 vertical asymptotes showing. And to get our cosecant, I simply go up from the peak and I go down from the trough. This is one cycle of our cosecant function, 2 cosecant x minus 1.